An interface is described as a group of related methods with empty bodies. If you are new to programming, understanding what an interface is and why they are used may be difficult. I'm going to break interfaces down for you to ensure you know exactly what an interface is and why you would want to implement them in your code. For starters, an interface will contain one or more abstract methods. Looking at this example interface, you can see there are two abstract methods, eat and drink. Since we have not yet covered abstract methods in this tutorial series, let's quickly look at how Oracle defines abstract methods in the Java docs. As seen here, an abstract method is a method that is declared without an implementation, meaning without braces and followed by a semicolon. Looking at the abstract method they use as an example, it begins with the modifier abstract. Next we see the return type void, then the name of the method, move_to, followed by a parameter list which contains two variables of type double. One is called delta x and the other delta y. Lastly, we see the abstract method ends with a semicolon. Notice there is no body to this method, and therefore no curly braces to contain a method body. Skipping over this section here, let's look at this note. It says, methods in an interface that are not declared as default or static are implicitly abstract, so the abstract modifier is not used with interface methods. It can be used, but is unnecessary. Going back to our example interface, notice the two abstract methods here follow the same conventions as the example used in the Java docs. Each has a return type, a method name, and ends with a semicolon. If parameters were necessary, a parameter list would follow the method name. Since these abstract methods are within an interface, the abstract modifier is not used as it is unnecessary. Now, abstract methods within an interface are public methods by default. We will cover exactly what this means in a future tutorial, but for now, just know that this means we do not have to explicitly type public in front of each of these method signatures like such. At this point, you are probably wondering, okay, so an interface kind of looks like a class, except it doesn't seem very useful since the methods contained within it are not defined. Why would I ever want to implement an interface in my code? To answer that question, let's refer to another page within the Java docs describing interfaces. Specifically, let's look at this sentence here. It says, there are a number of situations in software engineering when it is important for disparate groups of programmers to agree to a contract that spells out how their software interacts. So what does that mean exactly? Considering this feed interface example, imagine we are creating a program that simulates the lives of numerous animals. If you remember how Tamagotchis worked back in the day, this tutorial may make a little more sense. If you don't, imagine a small handheld device that allowed you to interact with a creature to see it grow and evolve, something like a Pokemon. Now, in order for the creatures to grow and evolve, they need to perform the basic functions of any living object, such as eat, sleep, exercise, etc. In our animal life simulation program, we would allow the user to select from a variety of animals to raise. Now, different animals have different needs to grow in a healthy manner, sort of. For example, all the animals will need to eat, sleep, and exercise, but the food they eat, amount of sleep they require, and amount of exercise they need will likely differ. In creating the individual classes for each selectable animal, we're going to need to ensure that each animal class implements the basic functions of any living creature, and we could do that by implementing interfaces. Let's create some animal classes now to get a closer look at exactly what I am communicating. Like always, we will create a new class in the interface example project folder here by right-clicking and going to new class. We will call the class dog, and we will not add the main method stub as this will not be the entry point for our program. Now we have an empty dog class template. As mentioned before, all living creatures have to fulfill necessary functions in order to grow and evolve. For starters, all living creatures need to feed. So in any animal class we will create, including this dog class, we need to ensure feeding is implemented into the class. And we can ensure that by implementing the feed interface. To do that, we simply add implements, then the name of the interface we want to implement after the class name. In this case, we will add implements feed. When we do that, we get a red line underneath the class name dog. And when we hover over the class name, the dialog reads, the type dog must implement the inherited abstract method feed.eat. Not only do we need to implement the abstract method eat from the feed interface, we also need to implement the abstract method drink from the feed interface. In other words, we need to implement every abstract method that is contained within any interface we implement. Looking at the available fixes here, you can see the first fix says, add unimplemented methods. And if we click that fix, Eclipse actually does implement all abstract methods from the feed interface. Now we must write the method bodies for these methods. We will keep the bodies of these methods simple. The eat method will simply print dog is eating to the console, and the drink method will simply print dog is drinking to the console. Let's create and implement another interface before we start to instantiate dog objects and utilize their functionalities within a main method. Remember that we want to create an interface that represents an action that will not only be utilized by the dog class, but will be utilized by any type of animal class we create, as theoretically, the action is absolutely required in order for any animal to grow and evolve. We can add another interface by right-clicking on the project folder, hovering over New, and clicking Interface. We will give this interface a name of REST, and then click Finish. If you look at the Java files within our project, notice a couple have capital I's in the top right corner. This simply signifies these files are of the interface type. Now within the REST interface, we will add one abstract method. It will have a return type of void, and it will be called REST. Going back to the dog class, we will implement the REST interface in addition to the feed interface, and we can do so by adding a comma after feed and adding REST. Once again, the red line reappears under the class name dog. And once again, it is because the dog class is missing the implementation of an abstract method that is contained in one of the implemented interfaces. And once again, we can simply hover over dog and select the first fix to add all unimplemented methods. In this case, it will only be one more method being implemented, the REST method. Like the methods implemented from the feed interface, we will keep the body of the REST method simple by only adding a print line statement that will print dog is resting to the console. Now let's put the dog class to use. We'll add another class that will be called Animal Farm, and we will include the main method stub on this class as it will be the entry point for our program. Within the main method, let's instantiate a dog object called firstPet by typing dog firstPet equals new dog. Next, we will verify all methods within the dog class work as designed. First, we will try out the eat method by typing firstPet.eat. Then we will try out the drink and rest methods in the same manner. When we run this program, we can see that it does indeed run as designed. Alright, now let's create another class of a different animal type to drill in the idea of interfaces. We will create a new class called bird. The bird class will also implement the feed and rest interfaces to ensure objects created from the bird class include the necessary functionalities to evolve and grow. We can hover over bird and select the first fix to add all unimplemented methods, and we will write the bodies of the implemented methods. Now you should notice that the bodies of these methods are similar to the bodies of the methods in the dog class, with the only difference being the word bird is used in place of the word dog, to signify the animal fulfilling the actions is in fact a bird. And that is all we will do with the bird class. Now let's go over to the animal class to instantiate a bird object that we will name secondPet. We will then verify all methods within the bird class work as designed. First we will try out the eat method by typing secondPet.eat, then we will try out the drink and rest methods in the same manner. When we run this program, we can see once again that it does indeed run as designed. Going back to the bird class, I'd like to point out that if any of the methods in the class are removed, the red line reappears under the class name bird. And when we attempt to run the program, we see the error. The type bird must implement the inherited abstract method feed.eat. As I explained before, we need to implement and write definitions for every abstract method that is contained within any interface we implement. In removing the eat method from the bird class, we are no longer adhering to this policy, and our program will not run until we do adhere to it. If we look back at the sentence from the Java docs that describes what an interface is, we once again see that interfaces allow programmers to agree to a contract. In this example, the contract can be defined as all classes created to represent an animal in the animal farm will be required to implement the feed and rest interfaces. The purpose of this is to ensure any or all classes created to represent an animal adhere to the same requirements and implement the necessary methods for the animal to grow and evolve. The actual details of the methods that are required to be implemented may differ, such as the bird class referencing bird and the dog class referencing dog in this example. If the classes created to represent an animal do not adhere to the requirements defined by our interfaces, we see Eclipse as a red line under the class name to notify the program of the disagreement and will not allow the program to run successfully until the requirements are met. In the next tutorial, we will continue working with interfaces by looking at the finer details of various interface conventions.